this should be 3 seconds off, and then so it's off right now, and then 3 seconds on. So it'll run for 3 seconds, stop, and then as you see, it's kind of cycling through the actual state logic that we just put in. Alright, so now that we know the foundational elements of a servo control system using either Studio 5000 or RSLogix 5000, just keep in mind my environment, I'm using Studio 5000 version 34, but it does not matter. The same principles will apply to all versions, whether it be version 19, 20, 21, 23, 24, 28, 30, 32, even again 34 right now. So with that said, let's go ahead and do some controls for this. Now, rather than just going ahead and just starting out throwing some controls in here, what I'm going to do is I'm going to show you what I like to do to make things simpler for myself. Is I like to come down here and I like to come down here to data types, and I like to come down here and make my data types. So I want you to highlight real quick the motion direct commands. Okay, so you have motion right here, like motion state. So we're going to have an MSO, MS off. And what you can do too is you can get like a notepad to make things easier on yourself, and come over here and get everything you need, like an MSO. You need a MSRF. You need a motion axis shutdown. You need a motion axis shutdown reset, and you need a motion axis fault reset. Okay, so those are the most common things. Okay, so then we have motion stop. Then we have, which is MAS. We have a motion home, motion axis home. We have a motion axis jog. We have a motion axis move, like a move to position. That's what that is. And then we have a mag, which is a motion axis gear. And then what you have too is you have your dynamic change and your RP. So I'm not going to focus too much on RP, but we'll do MCD as well. So you do have motion group stuff too, but we're going to this is going to be basic controls. So what we're going to do is come over here and have this pulled up. Now what I want to highlight real quick is coming over here, we're going to make a UDT, which is a new data type. Okay, and then in this data type we're going to call this basic motion motion controls. Okay, so that's going to be the name of our data, or the data that we're going to be using. Okay, so first we need to add in a couple things. We can grab this. We're going to copy that and put that in here. And then the data type is, this is going to be really simple for you. It's going to be servo. So, or actually motion, I believe. So motion. So not motion group, but motion instruction. And you can make as many of these as you choose to want or choose to use. If you just make one, it's just going to have one. But if you choose to use the motion axis on, let's just say you're making this UDT for like several servos, we're going to build this up. Let's just say we're going to make 10 servos. We're going to need 10 actual motion axis ons, right? And then we'll come over here and do our off. Okay, so this is going to be an off, and this is going to be the same exact thing. All right, so motion, and then again instruction, and then take this up to 10. Okay, so we're going to keep repeating this till we have all of these in here, And so this is basically building a UDT right now. So, and this is not necessarily the quickest thing to do right off the hand, but it will save you a tremendous amount of time when you're going and actually doing the programming, because this is now a data type that you can turn to have in your tool belt to help you. And I'll show you that. So we're gonna come over here and continue making our motion groups. So motion instructions. So we're going to come over here, and actually I added that falsely, so I'm going to add that. I'm going to add 10 of those. So I meant to add all 10. I only have one servo, but maybe I want to have multiple resets for that one servo. I don't know. It could be that I use it in the program and I want to use it multiple times, right? So I'm going to have maybe control the resets from multiple different areas. Alright, so now we're going to go to our movement, which is our motion axis stop first. Alright, so we're going to do motion axis stop, motion, and then instruction again, and then 10 of these again, like we did. Sorry about you having to hear my mouse click, but that's just part of the that's just part of programming. So I'm sure when you program, you hear your mouse click as well. So when you do this, and I encourage you to follow along if you can, because that's basically, if you're anything like me, you learn from doing as well as seeing. So if I don't do it, I generally don't retain it as well. So I can encourage you to actually come in and do the same things we're doing right now. Right, so do the task as I'm doing it, so that you can kind of understand. If you need to pause this or whatever the case may be, then go ahead and pause it, and then go ahead and catch up where you can. I do know that I'm not doing this at a extremely fast pace, but I am explaining it as well. So hopefully this does give you a nice subtle pace where you can keep up as well. All right, so we are at our last one. Actually, we have two more, which is our motion gear, and then we'll come in and put motion instruction right here. Even though you don't type it right, it does pop up. And see, I didn't put 10 again, so let's go ahead and add that 10 back in there. And I'm doing all this online. Okay, so at this point, you do not have to be offline to make a data type. So just keep that in mind. That's a very helpful tip right there, because some things you do have to be offline and some things you don't necessarily have to. So when it comes down to it, this is something you can build while you're online. Alright, so now we're going to hit apply. We're going to hit OK. And if we go in here, we have our motion group now, or we have our basic motion controls. So now if I come over here and add a rung or something of that nature, so let's add in a rung, and I wanted to have like a motion like a motion command or something of that nature. Let's just start with a basic command or something like that. So let's go expand this over a little bit and then scroll over to motion. So you'll see like motion state, that's going to be your MSO. Again, like if you wanted your motion on. Personally, I like to turn my motion off to begin with, and here's the benefit to it is what we just built a UDT for this. So here's the benefit. We're going to point to our servo, which the only servo we have right now is the trainer servo, and then we're going to go to our actual motion control. And in our motion control, we don't have any tags yet, but what we're going to do is we're going to name a tag, and then we're going to call this motion controls. Alright, so motion controls, and then instead of our data type being motion instruction, what we're going to do is we're going to change that to our custom data type. So we call that basic motion group. Alright, so right here, let's add that in there. and you see it comes in motion controls, and then we're going to drag that down and then go to MS or the MSF, right? And we're going to use the very first one of that. So that's going to turn our servo off, right? Now we do need to have some controls in here, but I'm going to basically throw in a couple different things to just really kind of throw in some base principles of just how we're using this and how we're controlling it. So the next one, if we wanted to actually double check and make sure our system is active, first what we can do is we can come in and turn our servo on if the servo is off. Now I'm going to show you these controls here in just a second, but in the interim, what we can do is get our motion axis on right here. And then at this point, we want to come in, and if we want to control it, we can. Personally, I like to generally throw in like some resets or something like that if it's faulted. So let's come over here and let's add a rung in here and add another rung in here. So one thing I do like to do is make sure that if I have a fault reset or something like that, maybe a shutdown reset, I actually come in here and put that in here. I'll also come in the same rung, and I'll also put in a motion axis reset. So I'm going to pick my axis that I want to reset right here. So let's pick that axis. Okay, put that in there. And then what we're going to do at this point is we're going to pick our obviously the name or the instruction name. This is going to be motion axis reset or shutdown reset. This is going to be motion or the fault reset. So if the servo faults out, we are able to reset it. Now I'm going to show you a couple different things in here. So let's go ahead and delete that. I'm going to show you a couple different things in here. As you see, it's X'd out right here because it cannot do that function. But I wanted to show you a couple of different things in here. So we're going to throw in some basic controls on the side of this first, and then we're going to come in and add the proper control elements to that. Now in this, we're going to do a let's make sure we can make sure it's stopped, or actually let's come in here, it should be stopped. So we're going to come in and throw in a jog, and we're going to have our servo, and then we're going to come over here and throw in our jog for our actual instruction name. So that's where this beauty of this UDT comes in. Direction is basically a 0 or a 1, and the cool thing behind that is that you can come over here and go to instruction help, and what instruction help will do is it will tell you. So you come down here and you can kind of see right here it says direction. Forward would be a 0 and reverse is a 1. Okay, so just keep that in mind if you ever had that question. Speed, we're going to keep it at about 2, and then speed units, I like to go with units per second because again servos based upon speed are the most accurate. Acceleration, let's put acceleration at acceleration rate at 100 or 1,000, and let's put units per second right here, and let's put deceleration rate 1,000. We're going to have deceleration units. The profile, this is interesting. So you have a trapezoid or an S-curve. So for those who don't know what a trapezoid is, let's go to our help file and let's look at a trapezoid, and it should be down on the very bottom. So I want you to understand what a trapezoid is. Let's see if it does show us. It should show us. Okay, so it does not seem to want to show us the trapezoid right here. What I wanted to do is actually show that, to show that what a trapezoid looks like. And let's see where we can get that. Sure, I'm almost positive that it's inside of the actual or the instruction information. So just keep that in mind. So this is troubleshooting motion actions, common attributes. Let's see. So the trapezoid, if we can kind of get down to a different point, a trapezoid is going to be basically a sharp transition. There's not going to be any smooth transition. If you wanted a smooth transition from point to point, you would do an S-curve. And again, an S-curve is going to be basically a nice, easy transition. It's going to transition up and then slightly get into position, or slightly get into the speed, desired speed that we have, which is 2. A trapezoid is going to sharply get to that point. So, and then jerk units, I usually put about 10, and then 10, and then jerk units, always going to be units per seconds again. Merge, we're not going to merge, and we're not going to have a merge speed. We're not going to position lock, and we're not going to have a lock direction. So this is pretty much there, and then we're going to have a motion stop. Okay, so this is going to be motion axis stop, and then the beauty of this is we come over here, put in our servo, then we're going to use our UDT again, and this is a motion axis stop, right? So we're going to come over here and motion axis stop, pick the very first instance of that. The stop type, you can do multiple things. You can do all, which if you want to stop all motion, that's going to stop all motion. If you just wanted to stop a jog, in this case we are just using a jog feature, you can just choose jog. If you're using a move, you can just stop a move. If you're using a gear, home, or tune, whatever the case may be, or test, you can. There's a ton of stuff you can just do. I personally like to do all. And then the stop change dynamics, I generally, if you want it to come down here and decel at a certain pace, you can put the decel right in here. Decel, again, units per second. Again, that's based upon speed. If you want to change the jerk, I generally say no on that, to be honest with you. But you do have to put a value in here, and then jerk units. Okay, so that's basically the stop. Now, there's some common things that I did not add in here, or I did not go over right yet, and we're going to come over here and talk about these right now. Now, before we do this, we're going to add in, on the back side of these, we're going to add in a couple transition points, and you'll see why I'm doing this in just a second. So I'm basically going to do a state machine. And I'm basically going to do a really simple state control, nothing like a, some people have said like a Rockwell real complex state machine. I'm going to do a real simple state control so that you can easily understand the functionality behind this. There's really no reason to be complex when you're trying to learn the basic fundamentals of servo controls. So what I'm going to do is throw in a move at this point. So each one of these will have a move, each one of these will have a move, each one of these will have a move, and as you see, all my rungs are starting to get to the point where they're obviously not acceptable. And then what we're going to do is we're going to have the state, which we'll have a compare, then go to compare, and then come over here and say, well, this is equal to, and then this is going to be, we're going to add a tag in here, and we'll call this, let's see, current state, and so current underscore state, so that when you're building a tag inside of ControlLogix, it does not like to have spaces. So you need to have some kind of underscore or even have it together. Current state, we're going to make that tag. I'm going to use a dent, and then in the next one I'm going to have servo, let's see, master state control. Okay, And then in this, I'm going to have multiple. So I'm going to have probably 10 or more. It depends on how many states you want to have. I'm going to have multiple. So if this is equal to, and then what I'm going to do is I'm going to select the one that I want. So this is 0. I'm going to choose the value of 0. So, and then I'm going to take the current state down here, and then fill in the current state on all of the bottoms, because this is obviously where I'm going to be moving. This will all make sense in just a second for those that are kind of new to controls. But when you come down here and you understand this, you'll see what I'm talking about. So in this one, we're going to choose the number 1, and then we're going to put a value of 1 in here. In this one, we're going to put, let's undo that because we dropped it in the wrong spot. Let's come over here and drop it down here, and this is going to be a value of 2, or number 2, and then we're going to put a value of 2, or 2. Okay. And to make this simpler, you could do 10, 20, 30, 40. I'm going to do 1, 2, 3, 4, just because of the simple fact of it limits confusion, right? So for the sake of that, but you can make this 30, right? But I'm doing 1, 2, 3, right? So let's just keep that simple for the sake of everybody that's trying to learn for the very first time, and especially state machines, right? All right, so this is going to be, and on the very bottom, what's going to happen is when this is done, I'm going to go back and start the process over. So I'm going to load in 0 into that. Now, what we're going to have here is we're going to look at the motion group. So I like to come in here and look at the motion group itself. So the trainer motion group, and I like to look at the status. Is it synced? Synced. What sync means is all the servos in a happy status, or all the servos. None of them are tripped out. All of them are talking. Everything is functioning. All the communication is there. So I want to verify that the communication is there. Okay. Now what I can do too, if I wanted to skip the off, I could just go ahead and put the off bit in there and monitor that as well. Meaning I could come over here to bits and have this just like this, and look at the trainer servo and look at motion axis status, the motion status. I'm looking for servo action status, as I believe what the tag is named. So we're going to scroll down here and get that. Let's see, I often pass it when I'm going through here, so sometimes I'll go into the monitor tags to get it, but again, because there's not necessarily an alphabetical order, just keep in mind this is just something I'm trying to show you so you can actually see that. And generally when I'm down in the guard stuff, that means I've passed it. So we want let's see, action status. See, I want to say this is an enable status. I want action status because action status, what it does is it's saying, is the servo on or off, right? So let's make sure we can find that. I probably passed it. You guys probably saw it. Let's see where it is. Actual value. Let's see. This is position. Actual position. Let's come over here and make sure we get the right one. So there's a lot of tags that come with a servo. So just so you know. Alright, so servo action status is the bit that I wanted. And I could just say ignore the off command if the servo is not on. Now what I'm going to do here is actually not use that, but I am going to copy this, being that we have it here, and I'm going to say is the servo on down here. So I'm going to change this bit to basically XIC to make sure the bit is on. So let's go ahead and delete this. I just want to show you can actually use that. So what I do want to do is actually come over here and utilize this to say, okay, did this happen, right? So we're going to come over here and we're going to drag this down here, and then we're going to make sure the servo is off. And then what we're going to do is, there's a couple bits in here. There's an enable, a done, and an error. So we want to look at the done bit, is the bit done, and then transition to another state. Now in this, we're going to come back into our compare, or we could just copy this. We can copy this, Control C, Control V, and look at the current state, and then make sure that the current state is equal to 1, and then verify that. Now in this right here is a little bit different. So I want to monitor a couple different bits. So the shutdown reset, I want to make sure that I'm looking at my, again, the trainer servo, and the shutdown reset. So I want to make sure shutdown status, is it shut down, right? If it's shut down, then I want to shut down reset. Now if it's in a fault state, then I want to reset a fault. So we're going to go to our trainer, come over here, and action. You can do action faults. You can do axis fault right here, and you can monitor that. Or you can come over here and just come over and add this in here and say that the compare is not equal to 0, and then look at the motion axis again, or the trainer servo, and then look at the axis fault, and then compare that against 0. If it's not equal to 0, obviously it needs to be reset. At this point, what we're going to do is we're going to verify that at this point we're going to verify that there is no shutdown reset. We're going to also verify that there is no fault, and we're also going to verify that, let's see, we're also going to verify the compare and make sure that these are equal. So we're going to say the servo fault status is equal to 0. So if it's not equal to 0, we want to execute the command. If it is equal to 0, if everything is good, then we want to bypass and just go ahead and go to the next state, meaning we know everything is satisfied at that point. Now this does still indicate that there is a problem with this rung. Let's see what that problem may be. I think it's because I'm using this is a boolean. So this is a boolean, this is a boolean, and this is a dent. I'm looking at that correctly. And these are in there properly. So let's see where the problem may be. Alright, so these are using these bits in the proper way. We'll assemble this real quick and see, and this is what it's saying, is missing the reference to an array element in rung 1, missing the reference to the array. Oh, well, because I didn't select the actual and there we go. So make sure you program correctly. So I was looking at all the bits as if I did something wrong. However, what the problem was the actual UDT that I was using, the UDT that we built, that we didn't have the correct one in there. Alright, so now we have everything in here for this state to go in and do its function. Now, when I turn it on, I want to make sure the action status is on, but I also want to make sure it's in the correct state as well. So I want to come over here and make sure that the current state is equal to 2. Alright, because that's what we're loading in here. And as soon as it's on, so actually this turns on. So all we're doing right here is we're saying on, and we're going to come over here, copy this, put that back over here, and put the opposite in here. So if it's actually off, then we want to turn it on, and then we're going to say action is on, and then we're also going to say that the action or the instruction itself is done. So in and the instruction itself is done. So then we're going to go, and after that's done, we're going to actually run it for a little while. And what we'll do is we'll throw in a rung to say, we'll throw in a timer to say how long it should run, and then we'll say servo jog timer, and then we'll just have it run for like I don't know, 3 seconds. Sounds like a plan to me. We'll have it run for 3 seconds. Okay, so what we'll do is we'll come over here and make sure that this is an IP. So very first thing I want to do is, this is the interesting part of, and hopefully you stuck with this, is I'm going to use the instruction again. Then you see there's an enable, a done, and a ER, and then an IP. IP is what they call in process. Okay, so I'm going to use the IP. I'm going to use the IP in here. So at that point, I'm going to use the in process, and then I'm going to say, okay, then I'm going to start timing. And then once the timer is done, what I'm going to do is I'm going to come over here, place the timer done down here, and then allow this to transition states. So the timer done, and that will transition states, and then we'll start the process all over again. So at this point, what we'll do is we'll come in, and we need to put in our control right here, because we didn't put in our control. So if we're in state 3, then we're able to jog. If we're in state 4, then we're going to immediately stop, and then we're going to transition down back to state 0. So we can actually say that the servo is not that it's done. So we can actually come over here and put this down here and look at this, and then say this is process complete. So process complete and IP are the same. Basically, our IP is in progress. PC is process complete. So let's go ahead and see what we have for this. Now, what I'm going to do is I'm going to throw in a start button to basically control this a little bit better. Start PB. Something that I can toggle, and that way we have control over everything. So this way you'll actually physically see the servo running. So what we're going to do is, now this is all going to happen really quick. So I want you to understand that this is cycling through this main task at 47 milliseconds. It's very quick. So you're going to see the transitions coming in here. If I programmed everything correctly, everything's going to run properly. So as you see, the servo cut on. Servo is running right here. You can see it is currently turning off and turning back on. So how we can separate that, because it's turning off and you can see it turning right back on really quick. What I want to do is put in a little bit of time between here. Let's put in a little bit of time to say, and then have another timer to give it some time to, maybe we'll say servo on timer. Alright, so we'll put in some time here, and this will give it a little breaking point, so we'll put in 3 seconds here, and then we'll come over here, we'll put in again this action status, so we'll turn on and make sure that the action status turned on right here. And then what we'll do is we'll put another bit down here to add that in there for the servo for it to wait 3 seconds before it actually transitions, right? Alright, so this will be a lot better. This should be 3 seconds off, and then so it's off right now, and then 3 seconds on. So it'll run for 3 seconds, stop, and then as you see, it's kind of cycling through the actual state logic that we just put in. So if I've taught you anything during this whole video, it's the structure of how to properly control a servo. You first want to turn it off before you do anything else. The next thing you want to do is make sure you check for faults. If there is a fault, you reset the fault, and then you're able to turn things on. Now there's probably a tremendous amount of more controls you can put in here that in your normal system that would need to happen, but in my case I'm just having a simple motor running on a simple trainer that I built, so it's very simple. I'm just utilizing these features, but the same order of operation for the servo to turn on, to actually move, to actually stop, to actually turn off, all that order of operation should be just like I just implemented here. You always want to double check that the servo is off. You always want to double check that this system, the servo, does not have a fault, and then you want to go ahead and turn it on. At that point you can do a jog, a motion axis move, you can do many different things. So with this video, hopefully you learned a lot out of this. What I'm going to do is this is why I added the push button up here, is I'm going to let it finish out, and it's going to go to 0. It's going to finish, and then it won't run again. As you see, the servo is not running, and it is controlled because the stop has not, or the off has not been pressed. So it's still being controlled, meaning I can't turn it, right? But actually, if I do turn it, let's see if I can fault it out. Yeah, so I can't fault it out because the tolerances are so high. But either way, this is basically some servo programming, giving you the proper order of operation, and maybe the next stage from the prior video that we did with the servo foundation. So this would be video 2 from that very first video. And I wanted to remake all this stuff because, again, servo principles and stuff like that, and me making videos have gotten a lot better over time, so I wanted to make sure you got the very best comprehension and learning from this as I can possibly give. And again, hopefully you learned a lot from this, and again, we'll see you guys on the next one.